Forum Borealis Paradigm Expansion.
Greetings from the north, citizens of the world, and welcome. Tonight we explore an alternate model of physics known as the electrical universe, or LU. And for that challenging task we could have no better guest than Australian physicist Wallace Thornhill. In part 1 he leads us through the basics of this dissident school, how it poses that our universe is wired, and brings us up to speed about their work. In part 2 we focus on how this theory is met in academia and the scientific world, demonstrating that there's no such thing as free science and that control mechanisms inherent in today's system rather than facilitate it is a detriment to neutral, objective scientific research. We'll not touch the cataclysm aspect now, reserving it for a separate show in order for us to go into depths. But first, a brief note on our guest. He earned his degrees in physics and in electronics at the University of Melbourne in '64. His postgraduate studies was with Professor Victor Hopper's Upper Atmosphere Research Group. However, before entering university, he became inspired by the controversial and groundbreaking work of Dr. Immanuel Velikovsky. Wallace Thornhill experienced firsthand the indifference and or hostility towards challenges to mainstream science and realized there's no career for a heretic in academia. Instead, he pursued an independent path and put his resources to practical work in real life. Simultaneously, he continued his obsessive study of cosmic electricity and Velikovsky's work. Wall Thornhill devoted much of his professional life to the study of plasma and electricity. After working 11 years with IBM Australia, he then moved on to the prestigious IBM Systems Development Institute in Canberra, among else working on the first computer graphic systems in Australia. Thereafter, he was employed by the Australian Department of Foreign Affairs. He was also technical support for the computing facilities in the research schools at the Australian National University, which gave him excellent access to libraries and scientists there. He also attended postgraduate courses in astrophysics at the University of London and meetings of the Royal Astronomical Society and the British Astronomical Association. Despite the increasingly dogmatic censorship imposed by scientific journals over the last century to the detriment of independent research, Thornhill has written many papers for various journals over the years, like the US journal Aeon and the Review of the Society for Interdisciplinary Studies, or SIS, in England. He even served as a council member of SIS for several years while working in London for the Australian government. His first peer-reviewed paper on the electrical nature of stars was published in the IEEE Transactions on Plasma Science in 2007. He also published a co-authored paper on the Martian blueberry and a co-authored paper in Japan on the plasma phenomenon at the centers of galaxies. In 2010, the European Telesio Galilei Academy of Science awarded him its gold medal. Today he is retired, but keeps working for the LU project, like senior editor for the Picture of the Day feature on thunderbolts.info, a main hub for LU, as well as his own website holoscience.com, where you'll find most of his work. As for his engagement with the Velikovskyan school, he was invited to attend their first international conference at McMaster University in Hamilton, Ontario in '74. There he met one of his future collaborators, David Talbot, but also Dr. Velikovsky himself. On a subsequent visit to Velikovsky at his home in Princeton, New Jersey, Wallace posed the key question: what is the true nature of gravity? This culminated in the LU theory, formulated together with myth expert Talbot, which now has a worldwide following. and insistence on empirical data from observations and experiments give their work true integrity. The LU model was first presented officially at the World Conference in Portland in 1997 and provoked great interest from attending astronomers, engineers and scholars. Workshops and conferences were subsequently held in Portland and Seattle. Booklets and CDs were produced. In 2000, Wall was keynote speaker in Portland along with the noted astronomer Halton Arp from the Max Planck Institute and the plasma cosmologist Anthony Perrott from the Los Alamos Laboratories. Later that year he shared the podium with Halton Arp at University College London, and in 2001 he was keynote speaker at the Intersect 01 conference in Laughlin, Nevada. This brought forth new alliances within the broad scope of the LU model, including Oxford biologist Rupert Sheldrake, cellular biologist Bruce Lipton, and psychologist Gary Schwartz of the University of Arizona. At the conference, Dr. Perrott provided experimental evidence confirming that electrical force is paramount in the universe, proving that gravity-only theories can no longer be sustained. Paramount in the model is the place of electromagnetism as distinct from gravity in the formation of the universe. The electrical force influences matter at all levels, from subatomic particles to galactic clusters, leaving little room for the disconnected fragments of modern theories. Wall has published several books with Talbot and many articles available for free online. He is also a favored guest among various radio shows and podcasts, and currently has Gaia TV create a series on our electrical universe. Welcome to Forum Borealis, Wall.
Thanks very much, Al, for the invitation. I'm pleased to be able to speak to somebody from Scandinavia.
Yeah, we're like Gordon White said to me. He lives in Tasmania. Mm-hmm. He said to me that now we're stretching the tin can line all the way across the globe.
Yeah,
and we're doing it again.
Yeah, I think it's important for me because some of the best cosmologists in the world come from Scandinavia, where they actually see the electrical activity in the sky.
You mean contemporary?
Yes, the Nobel Prize winner Hans Alfvén in his Nobel Prize acceptance speech pointed out that cosmologists should witness the auroras because that's an example of the electrical nature of the universe.
That's interesting. I've heard different explanations for that, and we'll get back to that. But sure. What I think we could do is to, in the first part, basically focus on the nature of the... very first, let's just go quickly through your resume, like who you are and what you've done. But then I think you present, and it will be a condensed version, obviously, because we don't have that much time. But if you could, in the first part, give us a gist of what electrical universe theory is.
Yes.
And then in part 2, I'd like to focus on the failure of academia. I'd say academia more than science, because science is an objective tool, I mean,
yes.
Not an institution, right?
Yes, people know what it's supposed to be.
It's supposed to be, right? And,
yes.
And we're having a series where the series is called The Crisis of Academia.
Oh, I see.
And we like to help people understand what the problems of contemporary academia is.
Yes.
And I've had, you probably know Michael Cremo.
Yes.
So no matter what one believes about his field, it should, he should be able to present it in a scientific academic way.
Sure.
But no, of course not. So he's told us about problems in his field. So now we have a completely different field with you. So
I see.
And I know you can account for this because when I did research on you, I picked up you were interviewed by a girl and you were talking a lot about basic problems of
yes,
how this theory has been met. So I think if you game for that, I'd love to do that in part 2.
Okay.
I'll probably be talking a little too.
Yes.
I can never shut up, especially not. I'm very passionate about this subject, about the crisis of academia. So I probably rant a little too.
I see.
You can see if you can get some statements in then.
Yes, understood.
So that's about it. And also indulge me, because I must admit, although I have done my fair share of reading in different scientific theories, I am pretty virgin to the electrical universe theory.
That's all right. You're not alone there.
Yeah, but lots of people I respect are supporters of it, so I figured I should give it its due eventually.
Yes.
And here we are.
Yes. I think the main thing is that it returns to classical physics and only deals with what we can objectively observe.
Right.
And it deals with experiment and the results of experiment. So I'm very pleased that the gods have smiled on us and allowed us to run an experiment in Canada called the Sapphire experiment.
Oh, wow.
It's a complicated acronym, stellar atmospheric function in... I can't even remember what the last two were. in response experiment. In other words, what we've set up is a model of the electric sun, and we've spent more than $2 million, probably closer to $3 million now on it.
Oh, wow.
And the model is quite simple, and the engineer who's doing it is an absolutely outstanding engineer. He's in charge. He was running a $100 million company, but got clobbered by the GFC when people wouldn't pay their bills. And he knew about what we were doing and just called me out of the blue and said, this is my situation. I'd like to help. What can I do? Nice. And so out of that sprang this experiment, and he's done an absolutely superb job of instrumenting it so that... we now.
Okay. Yeah, I have a million questions about that, but we'll take that later.
Sure.
We'll save the juice so we don't have to rehash it.
Yeah, the basic thing is that we return to the classical physics idea of trying to simplify. In other words, trying to explain things in very simple terms.
Okay. Well, then I'm already a supporter. But by the way, a lot of people we have, I don't think, know you. So before we go to the ideas, I want to talk a little about you.
Yes.
And now, obviously, you live in Australia.
Oh, yes, born and bred here.
And, and I have to say, Wal, how did we end up inviting you on? Well, I'll tell you. I remember a friend. He's into interesting stuff like anti-gravity, free energy, like science, but fringe science, right? He was the first who mentioned electrical universe, but I never looked into it. And then after we started our podcasts back in 15, I think, was it? Yeah, 2015. And after probably a couple of shows, someone said, hey, you gotta get these electrical universe people on. I said, okay, well, that's interesting. Well, okay, duly noted. And it didn't last long. Someone else said the same. Talking about listeners now.
Yes.
And then someone else, and then someone else. And I have to tell you, in all honesty, you are probably the most recommended by our listeners to get you on. Yeah, it's amazing. And I Googled, and okay, you have a big following, but there could be other things they were asking for. So I think that says more about my listeners, actually, than it says about your stuff. So yes. I had no choice. I had to get you on. Popular demand, as they say. So you certainly made an impact. But that said, although you have passionate supporters, and some of them listen to us, I'm pretty sure most of my listeners are not too familiar, so we'll remedy that today.
Good.
So let's start with when we have a guest on for the first time, I have to ask about personal history. So let me ask you about your scientific background and how you ended up in this so-called do you call it EU?
Yes, that's right. It's a bit confusing.
Okay, it is here.
Yes,
there is another EU that I don't like, but this one I think I will like. So tell me about this.
Yes, we have actually a conference in the UK at Bath University in July this year, and of course it's advertised under EU in the UK. And so if you Google it, all you get is European Union information and pages and pages of that. Unless you specify more strongly that it's the electric universe or Bath, you won't find us.
Right.
But anyway, that's just how it's worked out. We were there first.
Oh, for how long has this been going on?
Well, it began in 1994, the collaboration, which eventually in 1997 was first presented as the electric universe. And that happened because David Talbot, who's probably the leading comparative mythologist in the world, invited me to a international conference that he was putting on in Portland, Oregon. And I'd known about him. I'd actually met his brother 20 years earlier in 1974 at an international symposium on Velikovsky's work called The Recent History of the Solar System, which, of course, is a challenge because the solar system is not supposed to have a recent history. They're talking about within mankind's memory. I met him there, and I reminded him of that fact and the fact that I'd also been pursuing what we were both there for, and that was to support Velikovsky's view that our understanding of the history of the human race and the Earth was totally governed by a uniformitarian idea that nothing happened in the past that we don't witness happening today. And Velikovsky challenged that, but in doing so earned the wrath of the astronomers of the day, particularly in America.
Yeah.
With the result that his book was effectively burned in the 20th century, which shows that the religious principle of burning books that you don't agree with still persists in cosmology.
Yeah.
So that's where it started.
But hang on. The theory itself.
Yes.
I know you talk about the organization about it, but who can we ascribe this understanding to?
Well, interestingly enough, the first time I've seen it used was in reference to Hans Alfvén's work in plasma research. And a title for an article written about Hans Alfvén and his research was published in the Boston Globe, I think it was. We would have been back in the 1960s, I think. And it was titled Alfvén's Electric Universe. And so, as I said, the Scandinavians can actually claim some precedent in all of this.
Now I have to be positively biased. So what about your journey? Did you start as a mainstream scientist?
I realized in looking back, and of course when you get to my age you can see the sort of path that you've taken, and suddenly realized that I was more or less destined to do what I've done, because even in primary school I was asking questions like, can Einstein be right? And things like that, because I couldn't understand how you could, how matter could have so much energy in it. That was that E equals mc squared stuff. But I realized that the inspiration for all of this came when I was midway through high school. That was in the 1950s. And there was a book published in New York and was the bestseller for 6 months called Worlds in Collision by a Russian emigre, Dr. Emanuel Velikovsky.
Yeah, I have that book. Love it.
Yes. Well, he was a classical scholar, and really he showed me that you have to be a classical scholar to do cosmology, because you cannot restrict yourself to mathematical theorizing or narrow specialization to understand the universe, because in doing so you exclude most of the universe, including us. And that is one of the key features of the electric universe. It brings everything back together again so that we really begin to understand ourselves and our place in the universe for the first time. So that was midway through high school. When I read it, my first reaction was, this is absolutely amazing, and I've never seen a forensic style investigation of global myths, because, of course, people more or less believe that they're kind of part of our growing up, and that initially we behaved like children telling stories, which were quite fanciful. Velikovsky pointed out that some of the things that were reported can be explained with modern physics, and he went about trying to do that. And his conclusion was, and he put this right in the very first few pages of that book, Worlds in Collision, is that there is something about the mechanics of the solar system and of the universe which we don't understand because it appears to be governed by electricity and magnetism. So that was the big clue that there's an electrical aspect to cosmology. When I got to university, by that stage, I was very worried that all of these experts and my teachers and that believed something different. And so I let it sort of sit in the back of my mind for a couple of years. But just before I went to university, I thought I'd better read that book again because I'll have a chance to talk to people about it, which I did.
Or so you thought.
So I thought when I got to university, I got hostility, or the experts would give me an answer which bore no relationship to the question that I'd asked.
Right.
But it was one that they could answer. And I became very disillusioned about that. But I persisted, and I realized, although I was, my honors work was in chemistry, I realized I'd have to switch to physics because that was where the answers would be found about gravity, electricity, and magnetism.
Right.
So I finished my degree, and I was accepted for postgraduate research in the upper atmosphere section. And that was about the closest I could get to space at the time. And but I realized halfway through that year that really academia was no place for somebody like me who was asking awkward questions. So I started looking outside for work, and I ended up joining IBM as a scientific programmer.
Oh, and when was this about?
That was I left university. I graduated from there in 1964.
Wow, then IBM, that was clever.
I thought so, because computing and that side of things, I loved the logical aspect of it.
Yeah.
And I ended up at their Systems Development Institute in Canberra. So I moved from Melbourne, the home where I grew up, and I thoroughly enjoyed Melbourne University, which is one of the leading universities in Australia, and was very sad to leave because when I was at high school, they used to ask, "What do you want to be?" And I used to say, "A nuclear physicist." But anyway, I gave that up.
By the way, do you have nuclear plants in Australia?
We have one research facility in Sydney at Lucas Heights, and in fact, that was where I became noticed by IBM for my ability to fix difficult problems. I'm a problem solver, really. And so they shifted me to Canberra to look after the Australian National University, which was wonderful because that was in the days of the moon landings and the return of rocks to the school of the Earth Sciences School at the university. Now, the ANU was more of a research university than a teaching university, so I had all of the top people in science in Australia that I could walk into their offices and talk to them. It was wonderful.
Yeah.
So it was almost as if the gods were smiling on me and they knew where they wanted me to go. Having left academia, I'd sort of fallen into a plum position where I was not responsible for anything that I said, but I had access to people who were doing the basic research on the moon rocks. And it was there that they were discovering things that they weren't expecting, but which Velikovsky had predicted back in the 1950s and 60s, earlier.
Like what?
The fact that the moon rocks would show remnant magnetism. Now, that wasn't expected because there was no idea that the moon ever had a magnetic field. But Velikovsky pointed out that all of the bodies, the Earth, Moon, Mars, and Venus, and so on, had suffered extreme electrical interactions within the last 10 to 20,000 years.
Even a child, if you look at a picture where you put up the planets and you see the tilt and the spin, it indeed seems like someone has run havoc through the solar system.
That's right.
Because they are all out of order in different ways. I mean, one of them is spinning the other way even, right?
Yes. Yeah. Well, I've often said the solar system, the planets are a fruit salad, because and yet they've tried to impose a model which requires that there should be a ordered gradation of properties from the inner ones to the outer ones, and that's not what we find.
No.
So it's been a case of trying to impose our beliefs on cosmology right from the very beginning. And in fact, cosmology has never actually departed from religious ideas. The Big Bang is merely a creation story with all of the miracles and so on still intact, which is quite incredible when you realize the amount of money that's being poured into looking for dark matter and dark energy and gravitational waves and so on.
Yeah. So we have a case here of trying to fit evidence to suit ideology, right?
That's right. And our education systems are designed to continue that and not change it.
Right. So I suggest that in part 2 we look more into how this failure of academia is, and in this part we try to understand better what you guys are saying is the case.
Yeah. Maybe I should say a little about what I've managed to achieve since I've so-called retired, and that is throughout all of my career I have collected information about scientific results that don't make sense according to the present ideas, the beliefs. And in doing so, I have been able to confirm the electric universe model at every turn.
Nice.
It either explains things more simply, or I've actually predicted them in advance of the discoveries.
And that is the definition of science, isn't it? Being able to predict based on facts.
Yes, that's it. Yep.
So we love anomalies here, so that's great.
And all along the way, I've picked up some gongs. The Telesio Galileo Academy of Science in Europe gave me one of their gold medals, and that was issued to me in Hungary in 2010. Nice. In 2013, I think it was, I was given the Sagnac Award by the Natural Philosophy Alliance, and another leading astronomer also received that award, so I'm very pleased to be in such company, and that was Dr. Halton Arp, who actually has observationally proven that the universe is not expanding. There was no Big Bang.
Wow. So the breathing universe, the contraction and expanding, is rejected in electrical universe theory.
Yes, his conclusion from his observations was that the universe is essentially static and much smaller than is presently believed. That is, I should say, just the visible part of the universe. But in effect, what he's saying is that the universe is of unknown extent and of unknown age.
But it's conceivable that it's finite, not infinite.
Well, we don't know. All we can say is what we observe, and what we observe shows no change as far as we can see. And this is one of the things, of course, that's a puzzle for the Big Bang Theory, because they're finding objects that are supposed to be at the limits of the universe, and yet they show the same characteristics as things which are up close, which, according to theory, should be quite recent.
Okay. Well, in the mainstream, in the schools and stuff, they teach the 4 forces, right? Electromagnetism, gravitation, and now comes 2 very bad words. I don't like them because they are misleading, but so-called weak nuclear force and strong nuclear force. Yes. Is that accepted in electrical universe model?
No. The electric universe model is a return to classical physics, which was more or less abandoned at the beginning of the 20th century with Einstein and Bohr, who stopped doing physics and began doing mathematics. And the distinction has to be made. Mathematics has nothing to do with physics. It is a useful tool when you know what you're talking about and you've defined all of your variables and so on, which is not done these days. So you really have to go back to the brilliant research and the theories and ideas of the 19th century, when so many advances were being made in electrical and magnetism theory. You go back to Gauss and Weber and the top European scientists, and don't ignore them, which the British have tended to do. And you look at what Newton did, all of the pioneers, and you work from there. You don't pay any attention to the mathematical nonsense, which involves dimensions that have no physical meaning, like space-time.
Yeah, so I take it you reject stuff like the superstring theory and stuff like that.
Oh, that's just, the more dimensions a mathematician adds to his theory, each dimension is another free variable.
Right.
It's another, it gives them more freedom to fiddle with the results.
Right. Mathematical gobbledygook.
Yeah. So the more the dimensions there are in a mathematician's theory, the further from reality they've departed. So as soon as we went to...
So in a way, it's a free-for-all. It's a way for them to explain away stuff they don't want to confront.
Of course.
They just introduce exotic layers.
Yes.
But what about quantum physics? You're concerned with macrophysics, but don't you guys recognize microphysics?
Oh, if cosmology has to deal with both ends of the scale.
Exactly, right?
That's right. You can't just deal with deep space and objects out there, many of which actually not observed, they're just surmised. And the electric universe does that. In fact, that was one of the key requirements of understanding gravity and magnetism, because at present there is no understanding of those forces. In fact, Einstein did away with the force of gravity, which is a rather difficult thing to do if you think about when you fall over. What is it that happened when you hit the ground? What was going on?
Yeah. To this day, it's basic in all schools, to say that we know gravitation is there, but we don't really understand it.
Yes.
I mean, after 150 years, that's kind of collapse. I mean, they should have something by now. So, but I guess you guys have a better explanation of these forces.
Yes.
You don't operate with those four forces, do you? You say everything is electromagnetism, and then the rest is just aspects of that, or?
I've gone the full Monty, as they say, and there is only a single force in the universe, and it is electric.
Yeah.
Magnetism and gravity are the response of normal matter to the electric force.
Right.
And it's a very simple model. It's a repeat of the atomic model at the subatomic level, so that we discard the neutron as being a stable particle, because we know it's not. It's observed to decay within 14 minutes when it's outside the nucleus. Mm-hmm. But it's never considered that the neutron is a temporary marriage between a proton and an electron to escape the magnetic field and the electric field of the nucleus itself. So it's a temporary arrangement, and it does not exist.
But that kind of makes sense, because these names are a little misleading, but to common folks out there, a proton is positive charge particles, an electron is negative charge, male and female, if you like.
Yes.
So then a neutron is just a marriage, because what you get if you combine plus and minus, you get neutral, right?
Yes, that's right.
So that makes sense, actually, yeah.
Yes, and the electric force is 10 to the 39 times, that's 1 followed by 39 zeros, times stronger than the gravitational force. So you can understand that the mere separation by the tiniest fraction of the positive and negative charge that must exist within the proton and the electron is sufficient to produce another force. And of course, if you have an orbital system, which is what we're applying the atomic model to an electron and a proton, then if you give a push to a satellite, say of the Earth, in one half of its orbit, and then the push is acting in the opposite direction for the other half of the orbit, what you generate is an elliptical orbit. And as soon as you have an ellipse, you have one charge sitting at one focus of the ellipse. That's the nuclear particle. Mm-hmm. And the ellipse itself has a negative end and a positive end at right angles to the electric force that's causing the distortion. That is the magnetic force. Mm. So it's very simple, and this is why the magnetic force is always generated perpendicularly to the electric force, the electric current. And as far as gravity is concerned, the nucleus is almost 2,000 times heavier than the electrons that are flying around in orbit about the atom.
Yeah.
So under the influence of the gravitational force, which is not shieldable, we know that you can't shield it with metal plates or electrically charged objects, the nucleus will fall towards the center of mass, the center of gravity. And that means that each atom in the Earth has the nucleus offset towards the center, which causes it to form an internal electric field inside the atom because the nucleus is offset from the center. And it's that weak distortion of the nuclear particles in that weak electric field inside the atom, which is the gravitational force, and that explains why it's 10 to the 39 times less powerful than the naked electric force. This has always been a puzzle for physics. How is it that we can leap away from the entire mass of the Earth? We should be only a few atoms thick lying on the surface if the electric force applied to us and the Earth. So it explains a lot of anomalies. It gets rid of all the mysticism.
Yeah, but do you reject the concept of, let's say, gravitons?
All of these bosons and things that are invented to save appearances, in other words, they invent particles to carry a force, is nonsense. The real answer is we almost had the electric universe model in our grasp in about 1870, because Wilhelm Weber produced an atomic model based on this simple idea of orbiting charge, opposite charges, from first principles. And his theory was called theory of electrodynamics.
Right.
We have a theory of electrostatics, which has the force between two charged particles is dependent only on the square of the distance between them. There is no time involved, you'll notice. It's instantaneous. There is no time delay, so time doesn't appear. Weber took the electrostatic force and said, let's generalize it so that the particles are not just sitting there statically and we're measuring the force between them, they're actually moving and accelerating. When he did that, he found that you form stable orbital systems. So there's your atom for you. You don't need any magical quantum theory, which is merely a recipe book based on statistics. Well, statistics is not a physical explanation. So applying Wilhelm Weber's law to quantum mechanics, it explains the so-called spooky action at a distance, which at present is not explained, and that is you separate two so-called entangled particles and over great distances, and you flip, say, the spin of one and its partner. It can be 100 kilometers away or thousands or whatever.
Yeah, this is the classic in quantum physics, right? I'm supposed to prove that there's a greater coherence.
Yes.
You're saying electricity is this coherence.
Yes, the electric force between all matter in the universe is the coherent aspect of the universe, and it's absolutely necessary. If it wasn't,
and it's instantaneously, it bypasses time.
Yes.
That's amazing.
And gravity is instantaneous. It's not, doesn't travel at the speed of light, so the gravitational wave detectors that they've built at great expense are a waste of money, because gravity doesn't behave as a wave. It's instantaneous. It's like you're connected by a rigid rod. If it wasn't for that, the solar system would fly apart because we would be orbiting where the sun isn't, and Jupiter would be orbiting the sun where it was hours ago. So if gravity traveled at the speed of light, it would act like a slingshot, where the force is acting slightly ahead of you all the time and accelerating you. This is so obvious. It's amazing that people, haven't recognized it.
Well, obvious for you maybe, but
Well, I think this is the way we're taught.
some people still believe in Christian fundamentalism as a cosmology, so
Yeah.
we're different. But let me see if I can try to dumb this down a little. Do you reject the notion of? I mean, obviously you accept atoms, right?
Of course.
Yeah.
It's a
What
very
about
successful model.
Pardon?
It's a very successful model, and it's withstood the test of time.
Right.
The problem is that there is no real explanation for it. Quantum theory treats electrons as a statistical phenomenon, and all you can do is predict the probability of an electron being found somewhere in orbit about the nucleus.
But if we go to subatomic particles, you
Yes.
guys accept electrons, and with that I mean or proton, electron, neutron, but you
Electrons and protons.
Yeah.
Electrons and protons. Neutrons are an unstable particle which only exist for
temporarily.
a short.
Yeah.
Temporarily.
But below that, that's gobbledygook.
What I'm saying is that you can explain magnetism and gravity in terms of going down one more level. And I think Einstein, even though he made some terrible mistakes, which we're still living with, he recognized he didn't like quantum theory. He doesn't like this idea that statistics rules the behavior of matter.
God doesn't play dice.
God doesn't play dice. Yeah. That's right, exactly. And he thought that it meant that there was something at a deeper level that we weren't understanding. And the electric universe says, yes, you got that right. We can explain magnetism and gravity in terms of an atomic structure of the electron and the proton. It's as simple as that. All these other particles, the zoo of particles that have been discovered, are merely short-term resonances of the bits that make up normal matter, the electron and the proton.
Right.
They've got nothing to do, they've got no real existence apart from that. And all of the gluons and quarks and that other stuff, I mean, they defy the principles of physics. The quarks are supposed to wink in and out of existence. Well, that's forbidden by classical physics because that's magic.
That is magical. It is magical thinking. It is.
Yeah.
But could you, in a layman's terms, could you say that the nucleus of the atom is like a sun and the planets are like the electrons?
In a sense, but this becomes very interesting. I mean, the discoveries keep coming simply because there's these sudden realizations I have that some of these great scholars of the past, and you have to dump a lot of the ones that we currently worship, were so close to the real answers, and it's just that we happen to pick the wrong people to follow, as they say. Some of the greats have stood on the shoulders of giants, the people who went before. The problem is to pick the right giant.
Wouldn't you say Tesla would have been an adherer to the electrical universe if he lived today?
Absolutely. He was, I think, one of these intuitive geniuses like Velikovsky, who made great advances and seemed to be able to almost visualize electric circuits in his head. The problem is it's very difficult to refer to his work because I've not been able to find the documentation that you need to be able to say, look, this is what Tesla did and this is what he said. He said a lot of good things. He said he dismissed Einstein's work as being, nonsensical, which it was and is. He had an inkling that you could produce a force like gravity, one which would knock things over at a distance, by setting up circuits and coils which generate magnetic force. And that's the magnetic force and the gravitational force are identical in their origin. It's just that they operate under slightly different circumstances. One is gravity is static, so to speak, because you've got a fixed body where all the particles are fixed in position in crystals and the structure of a massive body. The electric force is due to particles in motion, with respect to one another. That's the only difference. There's this is the thing. Once you've got these basic, simple principles in mind, all sorts of realizations come, and you're able to say, I understand that. If a new discovery is made, you say, yes, does this fit with this model? And I've never found anything which doesn't fit.
That's a good sign.
And when they discover things in space, I look at it and I say, yes, I can understand that in electrical terms, even though you're puzzled. And the puzzlement is endemic in cosmology these days. The latest one being the discordance between the background, so-called cosmic microwave background radiation, and the distance measurements made using modern techniques of the so-called expansion of galaxies from one another. They don't match. And this is a huge problem. But nobody ever goes back to look at the assumptions that are built into Big Bang cosmology. And when you go back and look at the very basics of it, it's not scientific. I mean, the Big Bang itself is not scientific. It has a creation event, and we can say nothing about creation. We do not understand where matter came from or how it comes into existence.
No, but to most people, nothing comes from nothing, right? So
yes.
They don't. I mean, it is a magic. What do they say? Give me one free miracle, and I can explain the rest, right?
That's right.
That's
yes.
kind of what they're doing.
Yeah, unfortunately, Big Bang cosmology is like those. I remember when I was a kid, we used to go to the Saturday movies, and they'd have a matinee adventure. And of course, each one would end up in a cliffhanger. And of course, when you came the next week, some miracle occurred and everything would be okay. Well, that's how modern cosmology reads.
Right. But, as we speak, they are boasting that they have taken a photograph of a black hole. And yes. I remember I was impressed. I was very young and I read about the Einstein Bridge. Yes. Quasars being the opposite of black holes. And so that the theories, this was popularized in Star Trek and stuff like that, that if you could adjust into a black hole, then you would be traveling through hyperspace or whatever they call it, and then come out on the other side. and now multiverse theory is very popular. So yes. How does the electrical universe theory relate to the concept of black holes, and also that it can be entrances to other dimensions or universes? And do you acknowledge that they even have photographed a black hole?
They haven't photographed the black hole. No, it's a constructed image, and it's not explained and it's been coloured in to make it look like what theory suggests would be found. And we're not told what the colouring means. Is that a reference to the different frequencies of that they observed the data, or they picked up the data, and then they constructed this image from that data. One of the problems today is that these very expensive experiments, what would be termed by another Nobel Prize winner, Irving Langmuir, who was one of the pioneers of the electric universe, if you like, who did plasma research, and he identified this kind of research they're doing today as pathological. In other words, you're scratching around amongst signals which are way down in the noise, looking for patterns which you want to see. So it's a bit like looking at a Rorschach test and seeing faces and things like that. The other thing is that it's not mentioned that the gravitational wave detectors had about 500,000 different faces that it was looking for. So the chances of finding something in amongst the noise to match their ideas was almost a given. Anyway.
So there's no black holes in the electrical universe theory then?
No. Black holes are invented because they don't understand gravity. If you don't understand what you're talking about, then you have to make up stories to cover the observations. And what we observe is that galaxies don't conform to gravitational theory. So there's been attempts to modify Newtonian dynamics called MOND, modified Newtonian dynamics. And they've introduced dark matter, which is undetectable by normal means, except that it has gravitational influence. Well, this is the ultimate in storytelling. It's magic, because all normal matter will respond to electromagnetic forces and produce signals other than just gravitational. So it really is magic. And now they're finding that dark matter seems to be unevenly spread. You know, some galaxies don't appear to have it and others do. So it's a matter of you just put it where it's needed to save the appearances. It really is incredible. It is pathological science, as Irving Langmuir pointed out. The electric universe has a very simple model, and it's based on Hans Alfvén's work and that of the plasma scientists who've, like Erwin Bostick and more lately Tony Peratt, who's written a textbook on the physics of the plasma universe. And he was actually worked with us for some years until, I can't actually discuss it, but we have some people who are what you call pathological skeptics. They're people who will try and damage your reputation.
Yeah, pseudo-skeptics.
This not just, yeah, but when they're actively trying to destroy your career because you've said something, then that is goes above and beyond being a pseudo-skeptic.
Absolutely. They are crusaders, ideologically.
That's right, yes. They're the fundamentalists.
Yep.
If you like, in the religious cosmology of the 20th century.
And we'll give them their due in part 2 when we go into the failure of modern academia, because I think they're not the entire problem, but they are a huge part of the problem, I say.
Yeah, it's a very interesting. In fact, I collect paper files as well as electronic. My biggest folder is on the sociology of science, because that you could write a fat book about that.
Yeah. And we could have a show about it too.
Yeah.
And we're having a series.
But getting back to the black holes.
Yeah, black holes.
Yeah. I'd like to get back to the black holes.
Yeah.
What we observe is that to explain the rotation of the spiral galaxy, there has to be a huge concentration of mass at the center, and also more mass, which we can't see, this so-called dark matter, floating around at distances outside the spiral itself. Now, the concentration of mass at the center is considered to be normal matter, neutral matter. You'll notice they never talk about electrified objects in space. It's because of the way astrophysicists are taught, and I've actually sat through the MSc course in astrophysics when I had the time. And I approached the guy who did the plasma physics semester at the end of it, and I said, when are we going to talk about electrical activity in plasma? And he said, oh, we don't do that. And I said to him, I think you may be missing something very important. And but he just, brushed it off and walked away.
I mean, that sentence there shouldn't be room for such a sentence in science. We don't do that.
Yes.
In church, yes.
You're quite right, yeah, but it is proof of the fact that the education systems fail us.
Yeah.
The answer is very simple. Hans Alfvén, amongst several other leading plasma physicists, have pointed out that the spiral arms are actually an electrical discharge phenomenon, which is observed in plasma. And Winston Bostick, I think it was, first demonstrated this in the laboratory. He could fire these plasmoids at each other and they'd end up forming a spiral galaxy.
Wow.
So electromagnetic forces govern the shapes of spiral galaxies, and they govern their formation. It is a normal plasma discharge phenomenon to form a spiral, rotating spiral in a very powerful electric discharge.
Yeah, because everything rotates in this existence, doesn't it?
That's right, and there's a big question about that. Where did that rotation come from? Well, the answer is simple. Electric current flows through space in the form of a helical structure of two filaments that rotate about one another. So any discharge between those two filaments will create a rotating object with two bars between the two spiraling filaments, rather like the rungs in the DNA ladder. And at the center, where matter accumulates, will be the central bulge of a galaxy. And then you get the bar of galaxies, and a barred spiral is a normal form of a spiral galaxy. And then you get the trailing arms. And even the fine structure of the trailing arms, which includes what they call diachroton instabilities, are observed in space. They're not explained by gravitational theory, but they are a natural phenomenon in plasma physics. So Hans Alfvén drew the circuit of a galaxy. He drew the circuit of the sun, and all of this is available, but it's ignored by astrophysicists because they don't talk about electricity in space. In fact, one of them said at one of our meetings that we know there's electricity in space, but it doesn't do anything, which is an incredible statement when you think about it, because when we discovered electricity, we found it did everything.
Yeah. And why would it be there?
Yeah, exactly.
Can something be there without having any effect?
Yeah,
that also sounds magical. But I'm brought to think about this Russian scientist and his stuff, which is called torsion physics. You are familiar with that?
No, I'm not. I deal with the basics, the very basics, and there's a lot of talk about vortexes and things like that, which are all great fun. But you've got to ask, what is causing the rotation? What is causing the vortex? It's not the first cause. The first cause is electrical.
Right. I'm looking for his name now. He is a very famous, he was active under the Soviet. His physics were suppressed. Torsion physics is about rotation, and they think that this may be the clue to free energy, anti-gravity, all sorts of stuff.
Yes.
And that's why it's been suppressed. And I starting to think there may be some relations between that and the electrical universe, because that would explain why they are suppressing the electrical universe. If it can have implications that they don't want in practical terms, you know what I mean?
I'm not sure that that's the case.
Okay.
In the Natural Philosophy Alliance, there are many scientists, including those from Russia, who would attend and present their work. The problem I found with almost every one of them is that they use the language of modern physics, and the language of modern physics lacks definitions. Would you believe that E equals mc squared lacks a physical definition for energy and mass? And if you're going to talk about the speed of light, it has to have a reference point. You can't talk about a speed without knowing what you're determining as the zero reference point. Of course, Einstein said that you could choose any observer you like, and the speed for him, for light, will be the same. Well, that's nonsense. What Einstein effectively did was to remove our standards of measurement, length, mass, and time, and made them rubbery, which means we were no longer doing physics, because physics has always relied on standards of measurement and a base. You have to have a base. And in the past, that used to be called the fixed stars. In other words, all the matter in the rest of the universe is the fixed base. And that base always is, without that base, you're not doing physics. And Einstein discarded that. So that was his contribution to modern physics. And all of these people who talk about free energy and vacuum energy and stuff like that are talking about probabilities. And probability refers to quantum mechanics, and quantum mechanics is a recipe without any idea of the ingredients. So, as I said...
But does electrical universe theory reject... They shouldn't reject anti-gravity, because if gravitation isn't a primary force, it should be able to be overcome.
The problem is you have to understand the origin of the force before you can defeat it. Yeah. And yes, anti-gravity is actually a force that operates throughout the universe, but we just don't recognize it. That's a funny story, really, when you think about it, because Newton had a strange relationship with this guy. What was his name again? in Fatio de Douillet, a younger man, who pointed out that the law of gravity, Newton's law, would operate quite happily if everything was being forced to respond to particles traveling through the universe and pushing them together. In other words, instead of being an attractive force necessarily, gravity was repulsive. Now, this was picked up, I think it was in the 19th century, by a fellow called Lesage, and it was called Lesage's gravity. And it does work, because the idea is that you've got these particles coming from all directions. I forget what they're called. They had to be extremely high speed and of low mass, and it had to interact with all the particles in that body. And two planets, or a planet and a star nearby, would shield each other from the particles that were coming from behind them. And the result was that the two bodies would tend to form a relationship, balancing the external force against this shadowing effect. Now, Halton Arp, I mentioned earlier, who was an outstanding astronomer and an observational astronomer who pinned up his pictures of galaxies and so on around his office wall and would sort of sit back and consider them. He was also the author of the Atlas of Peculiar Galaxies, because he collected peculiar ones to try and determine if there's any a pattern in their growth or structure or something.
That's a book. It sounds like I want to read.
Yes. His book that is probably most readable is Seeing Red, and you can understand why he called it that, because he, as a result of actually finding evidence for a static universe, submitted his paper. And I should say at this stage he was one of the leading up-and-coming astronomers in the US, and was a student of Hubble, actually worked with Hubble for a while. And when he submitted his paper, Subramanian Chandrasekhar, who was one of the leading astrophysicists of the day, scrawled across the top of the paper, "This exceeds my imagination," and it was rejected. Now, that is absolutely incredible, because something that exceeds the imagination of an astrophysicist should be of interest.
Absolutely.
It requires investigation. But what they did was they gradually reduced Halton Arp's telescope time, and then forced him more or less out of the business. So he went to Germany and worked in the research institute over there, where they were looking at X-ray images from space. And he was able to show the same results using their work as well. So Halton Arp was supported by Sir Fred Hoyle, by the leading astronomers, Geoffrey and Margaret Burbage, who all pointed out that the chances of him being wrong were millions to one based on the evidence that he'd assembled.
Wow.
But as I say, modern cosmology has not advanced beyond the creation myths of ancient cultures, and still treats it as a religion,
right?
Which is most unfortunate, because it's wasted a huge amount of money, right. And it's prevented us from really understanding ourselves and the universe.
Yeah, it's keeping us down.
Yeah.
By the way, the torsion physics thing, I remember the name of the scientist. That's Kozyrev.
Oh, yes.
You should look into him if you're not familiar, because if you have it like, you see something that's true, they're onto something, but they can't figure it out, then
yes.
and you can fit it into the electrical universe theory, then you should do that. Because I think that stuff like Kozyrev and Tesla and others who have been researching in areas which are threatening to the current status quo. I mean, one thing is ideas can be threatening, right? But
sure.
But in the old days, that was enough to get you smacked down. But I think today it's more practical. If you challenge power, money, technology, military, that's when they are intervening. So if the electrical universe theory can explain many of these things, then I get why it's blacked out. Are you familiar with another guy who is a contemporary? His name is Maurice Cotterell, and he claims that he can explain. He says, for example, that gravity is electromagnetic too. He says that he has this book Future Science, and he says that he can explain everything about gravity. But from what you're telling me, it sounds to me that it's pretty similar to the stuff he's doing. Are you familiar at all with that?
No, we have people who support us, and the Thunderbolts group, I should point out, is the American center of all of our activity now. The website thunderbolts.info has hundreds of hours of videos and blogs and whatnot, which go through all of this information. But in particular, there are some who, one in particular, Chris Reeve, who looks into controversies in science, and he looks at what other people are saying and the reaction to what they're saying as well. And if these people had come up with something which impinged on the electric universe, I'm sure they would have drawn my attention to it. Because
well, but the problem is Cotterell is very old and not active anymore. He's retired, so he may have gone under the radar. But if your colleague is listening now, check out Maurice Cotterell and his book Future Science. I have tried to get him on, but he's very old school, so I'm not even sure he does this kind of interviews. But I'll not give up. We'll see. But okay, now I have a million more questions here, and I see we're officially closing up to a break, but let's see what we can do. What about, well, let me first start with this. What about light or photons?
Oh, I see.
What's that role?
Well, photons can't exist because they're supposed to have zero mass, particles with zero mass. There is no such thing in the universe as a particle with zero mass. Because to be a particle, they would have to have structure, and that electrical structure, and that would respond to the matter in the rest of the universe. And so it would, it's the old problem of trying to transfer energy and inventing a particle to do it. And also it involves infinities. The idea that you can have a particle of zero mass, but yet get it to reach the speed of light, which according to Einstein's theory requires infinite energy, would require zero mass, but multiplying zero by infinity doesn't give you a number, because infinity is not a number. You can't use it in mathematics.
It's like zero, isn't it?
Yes. Well, zero is a useful concept, the absence of something. But the electric universe subscribes to the idea that the light itself, to have a waveform, must be a disturbance in a medium. You cannot wave nothing. So there is a medium, and space is full of it. And back in the 70s, there was a radiation physicist who proposed that the universe is a plenum, if you like, an ocean of neutrinos. And he went on to present his arguments as to why that was so. And I found that to be a very useful model, because it would explain the transfer of electromagnetic radiation through space. And it would also explain what's called gravitational lensing, because being normal matter, having vanishingly small mass, it would still respond to large objects with a strong gravitational field and form a kind of extended atmosphere about that object. And that object can be a star like the sun, or it can be an entire galaxy. So yes, lensing occurs, but it is no different to diffraction in the Earth's atmosphere. Gravity is not responsible for bending light. It is the atmospheric material that it forms around ponderable bodies in the universe. Also, it was shown by another physicist from the Natural Philosophy Alliance, Dr. Henry Dowdy, that the deflection that is measured by radio waves past the sun indicates that the deflection is caused by the plasma near the sun. But I would go further than that and say that at greater distances from the sun, any deflection of light is caused by the more dense atmosphere of neutrinos around that body. Neutrinos are essential, actually, in the electric universe theory to explain quasars. The ejection of these objects from the centers of active galaxies, which was Dr. Halton Arp's, the basis of his research, which showed that the universe is not expanding. Because he pointed out that redshift is not a measure of, it's not a Doppler effect at all. It's something that occurs in the very matter that's ejected from the active galaxy, because initially it appears to have very low mass. And that mass increases over time. And the question is, well, how does that happen? Well, it can happen if the proton and the electron in those objects is of a different mass to the proton and the electron in the Earth's environment, in our galaxy. And this turns out to be very simply explained because Halton Arp found that the redshift of these objects is quantized. And quantization of radiation is an atomic effect, a particle effect. And of course, that means that a lot of the constants in the physics books are not constants at all. They just refer to things as they are on Earth. And we've made the mistake, and we continue to make it, and we've done for thousands of years, of trying to explain the universe in terms merely of the things that we observe on our little Earth, traveling around our insignificant sun in an insignificant galaxy in a huge universe.
So in the electrical universe theory, although you say it's not infinite, because we see here...
No, we can't say. We don't know what we mean by infinite anyway.
Okay.
All we know is that it's of unknown extent and unknown age. Because we can say nothing about a creation event since we don't understand matter itself. Certainly, the idea that the Big Bang occurred from a point source, which is non-physical, and with phenomenal energy, which is not defined in modern physics, is just, it's unbelievable. Energy in the electric universe is defined as the motion of matter with response to all the matter in the rest of the universe. And since all matter in the universe is an electric charge, it is due to the electric force between all that matter. And the more rapidly you're moving in respect to the matter in the rest of the universe, the more energy you have.
So, but how would you define, we should probably begin with this question, how will you define electricism?
Oh, now, the electric universe...
Because if that's the cause of everything, we should have to start defining it, right?
Well, the electric universe, as I said, we go down one more level than the standard thinking with the atomic model.
Yeah.
So the electron, proton, and the neutrino must have orbital structure. But we still don't know what is inside that orbital structure. So all we're doing is pushing the mystery down one more level. And we have no idea how far down you have to go. But there are clues.
Yeah, but hang on. It's the same if you go up. Because we see that solar systems are whirling around a central sun, if you like, and so galaxies, and then they talk about clusters of galaxies. So I see the same principles in macro as I see in micro.
Sure, that's right. We don't know how far it goes in either direction, and where we sit in relation to whatever it is we are in this universe. But that's okay. I think the important thing is to understand that when you go from one scale to another, when there's a vast difference in those scales, you cannot assume that the electric force is operating, or in the dominant form of that force is the same at each different scale. And this is important because once you get beyond the solar system, you are not looking at a gravitational system, you're looking at electromagnetic universe. So you have to apply electromagnetic laws. In fact, I've often said electrical engineers should be cosmologists, not the ones we've got there at present. And that's true, because Hans Alfvén was in effect a very good electrical engineer.
Mm.
And a lot of his ideas came from practical research into power transfer over continental transmission lines and that kind of thing. And he saw the effects that can occur when you do something stupid, and they can be quite catastrophic and dramatic.
But then there's just a half step from electronics to music. Then you should elevate musicians too.
Oh yes,
because they're working.
In fact,
and from musicians to there's a half step to ancient mystics.
This is the thing about the electric universe. No one is unwelcome to make a contribution. In fact, we do welcome artists. We've had poets, we've had painters, we've had musicians, all inspired by what we're doing, simply because it shows the connectedness of all things, which is something.
Yeah, but I'm thinking especially musicians. Well, also artists, because they work with color. But I'm thinking the system of harmonics.
Yes.
Is so relevant here. It's just that they are just working with the audible scale.
Exactly. In fact, harmonics are basic to life.
I totally agree. In fact, I wanna throw something at you because my geeky stuff has to do with ancient Greek philosophers.
Mm-hmm.
And there is this conundrum, and I'm going to present you a case, and then I want your take on it. So there is this classical problem of waves versus particles we have in modern science, right? But I think the ancients solved that, because they talked about ether obviously meaning divine fire, and they believed that ether consisted of infinite particles which were kept in uninterrupted vibration, and these particles they called eons. And they not only filled matter, but they also filled space and time. However, they distinguish between the form the particles assumed in material substances and the way they manifested themselves in the apparent void that separates them. So you can say the eons filling the space, they vibrate without propagating, without transmitting, and they follow a wave motion, whereas those who form matter are subjected to constant movement and extreme velocity, and are also subject to a scattering motion. So although they distinguish between the wave and propagation movements of the subatomic particles, they knew that the wave responds to the manifestation of eons outside matter, and the other to the way they manifest themselves in material bodies. And I think that's a beautiful solving of the wave versus particle problem that they're still bickering about to date. So what's your take on what I just said?
Well, I think at an intuitive level, and I must say the electric universe has relied very strongly on intuition, an intuitive view of what's right and what's wrong, and also not rejecting material that is appears on the surface to be out of hand or doesn't conform with what's believed at present. All of these things have contributed to the electric universe model, which has now encompassed biology, living systems, as well as planetary systems and stellar systems, and throughout it all, it involves the resonant behavior of matter over distances. In other words, you begin to understand that consciousness itself is not contained within the brain. It's we're more like a receiver and sender, because.
So you subscribe to Sheldrake's take about what is it talk about a field?
Absolutely.
Yeah.
Yes. And he's what I would call a great scientist, because he devises simple experiments to test these ideas, and so far he's had great success.
Sure.
And yet his book, when it first came out in the 1970s, was subjected to a comment by the editor, Maddox, of Nature magazine, saying it was fit to burn.
That's always an honorary mark in my book.
I think as soon as somebody says that, then
Yeah.
you want to
know
go,
they're onto it.
You go and read it, yeah, because in fact, some years ago, I used to write letters to the Canberra Times, our local. When I say local paper, we're the national capital, so it has more responsibility than the usual local paper.
Mm-hmm.
The science editor dubbed me the boundary rider of science, and I thought that was very appropriate, because I'm always looking for where there's a great cloud of dust being raised by the herd,
right.
having a look and seeing what it is that's agitating them, and usually that's where you find answers that you were looking for. Somebody
that is the only way to get out of Platon's cave, isn't it?
Yes.
But I didn't quite grasp. What's your take on the wave versus the particle controversy?
Well, the wave versus particle theory, the wave or particle, depending on what experiment you're doing and what you prefer to use as the concept behind it, shows that the light itself is not understood. It's as simple as that. When Einstein removed the ether, he was trying to reconcile Maxwell's laws with mechanics. And in doing so, he knew that there had to be an ether, but for some reason, he seemed to, his special relativity theory did away with it.
Yeah, tragically.
And he never explained how you could do that. As soon as he did that, he lost all means of explaining it. And so it's been a case of a mere matter of arbitrary choice, whether you talk about photons or a wave. The electric universe points out that neutrinos, being normal matter, can be polarized by an electric force. So if you have moving charges, they exert a changing electric force on nearby particles, which will force the distortion of those particles, even if they're neutral. And a neutrino is electrically neutral, but obviously it must be composed of positive and negative subparticles. Okay, so if you have an alternating electric field in an antenna, the neutrinos nearby will have to rotate their dipole in concert with the frequency of the signal that's being radiated by that antenna. Now, that happens to the nearby neutrinos, and as they rotate, they then affect the neutrinos that are more distant, and so on. So it's the rotation of the electric dipoles of neutrinos which carries the wave information. It is a transverse activity.
Yeah.
And that means that the rotational inertia of the neutrinos will determine the speed of light, and also their density, how many you've got between you and the receiver at any given point will determine the speed. Now, of course, this is what we observe. Light slows down in water and air over what we measure in a vacuum. And we realize now then that a vacuum is full of neutrinos. You cannot keep them out. They'll pass through the walls of your container.
Yeah, space is not empty.
Exactly. And this is the failure of the gravitational wave detector. There you've got the biggest vacuum chamber on Earth with the most perfect vacuum they can get. It's full of neutrinos. So if you have a disturbance in the ether passing the Earth at the speed of light, that's all you'll detect is a disturbance in the ether. It says nothing about gravity, which is a longitudinal force, not a transverse force. So if they're detecting anything, it's a disturbance in the ether.
I love it. You recognize ether. That's so great. But so transverse, sure. What about the idea that particles can breed or transmit, that they actually move, not just a transverse movement, but an actual spreading movement?
I'm not quite sure what you mean there, but
well, you have in a way, right? You have the idea that the particles are not actually moving, but that they are pushing.
Oh, I see. Yeah.
I guess that's what you call transverse, right? And then you have the idea that no, it's the particles that's actually moving all the way from A to B.
Oh, I see. Yeah, I think they call it the scalar.
I use layman's terms. I'm not a scientist, so yeah.
This is the problem. Modern physics is full of misleading language. And,
Yeah.
and this is what I find with those people, like the ones you mentioned. I read their material, and as soon as they start using words that are undefined or have no meaning, physical meaning, I realize that they've unfortunately wasted their time.
Right.
Although their fundamental thinking may be along the right track, they've lost any physical meaning to what they're talking about. And this happens almost.
And that's the schools are to blame, because they impose upon them more and more esoteric language that removes it from practical terms and layman understanding.
That's right.
I think it would be much more, if it was more available and more kept in touch with the culture, then we would have much more brain power coming into these fields, not just these nerds that suffer through all this meaningless education, right?
Unfortunately, we're taught so-called facts, which aren't facts.
Yeah.
What is needed to educate a student and make them fit to be a scientist is to present them always with alternatives, so that they have to go away and think about who has argued the best case and then make a decision.
Exactly.
In other words, they're forced to think about alternatives. This is why now when scientists are faced with a conundrum, they don't have an alternative. They say it's back to the drawing board. But what do? They leave what they had there before on the board and just scribble around the outside. What they've got to do is wipe that board clean and start again.
I totally agree. You know, let's get more into this in the second part, and we'll take a break now. But just you were addressing the particle spreading, breeding thing, the transmission of particles.
Yes. Okay, there's two different activities of the neutrinos between one object and another. The one we spoke about was electromagnetic radiation, which is a transverse effect caused by the rotation of an electric dipole between you and the receiver, the transmitter and the receiver. The gravitational force is longitudinal, and it's just like a stretched wire between the two objects, and it's just a daisy chain effect where there is a tiny dipole, electric dipole, transferred from one neutrino to the next, directly facing towards the receiving object. And because the neutrinos are not having to rotate, because the motion of the object at some distance is, it's almost unmeasurably small, then any motion, acceleration, or whatever between the two, any force between them is transferred instantly. There is no speed of light delay because you're not talking about the rotation of the transferring particles, the neutrinos. It's like they're all lined up just like a taut object.
Yeah, like billiard balls.
Yeah, there's the difference. Wave and gravity, the difference is like that of stretching a rope between two people, and one end waves it up and down, and the wave travels slowly down until it gets to the other end. That's your light. But if one tugs on the rope, you feel it much faster.
Yeah.
The speed of sound through the whatever it is between them.
So both phenomenons are a part of...
Yes, and neutrinos must be deformable in 3 dimensions, which means they must have a spherical orbital system, just like an atom.
Then it sounds like the electrical universe theory is fully in harmony with the ancient Greek take on this.
Yes, I think intuitively we've always had this notion that there's more, there is a soul, for instance, there's something beyond the body which is related to you, part of you, but it's not visible and it's not detectable by modern techniques. And we know that the body itself is electrically driven because you get electric signals from the brain, from the nerves, from the muscles, and so on. The whole thing is electrical. The beauty of biology is that there is this other signaling system which scientists are unaware of, and that is this direct transfer of resonant signals between all molecules of the same structure within the body, so that your body operates in real time, not with nerve delay times and speed of light transferred delays. All of these things would mean that we wouldn't be able to operate the way we do We wouldn't be able to synchronize all the bodily functions, all of the millions of chemical reactions that are taking place every microsecond without this instantaneous connection throughout the body, and not only that, but beyond the body.
This opens doors to so many interesting... damn, I wish... we have to take a break now. I think I need to invite you back to for a second discussion, because I want in part 2 to discuss, like I said, the failure of academia. But yes. I realized the electrical universe is opening so many doors. One of them you open is the notion of consciousness and soul. That's very interesting.
This is the thing I say to people, that a real cosmology can have no exceptions, and it must address a question from any discipline.
Everything.
Because it cannot exclude data, observations from any source.
No.
Yeah, in fact, the structure of the Earth and stars and that is quite different to what people think.
Right.
This whole idea of hot centers and radiation coming from within and all that kind of thing is because they don't understand how these objects are formed in the first place, because gravitational theory doesn't explain it. It's just a story. And also, if you don't understand gravity, you can't apply Newton's law inside a planet or a star, because the center of mass is an imaginary point.
This would be relevant to the catastrophism subject, right?
Oh, yes.
Yeah, because another thing that I associate with the electrical universe is catastrophism. It's an interesting approach to catastrophism.
Oh, that is so important for us to understand, yes.
But I think that's an entire show in itself.
Yeah, absolutely.
Would you come back and we'll do a session on that?
Sure.
Okay, then you can account for that when we do a follow-up with you.
Yeah, I think that's probably... Velikovsky himself, that was the most important understanding for humanity, was to understand ourselves. Otherwise, we're in danger of destroying ourselves in a repeat of a past trauma.
Yeah, exactly. So today we have scratched a little understanding about the theory itself. Now in part 2 we're going to take on how it's met in the world, and then when you come back we'll take on this implications of it, the serious implications like catastrophism. But let's take a short break, a couple of minutes, and continue this feast when we get back.
Okay.
Yeah.
All of our files are free and will remain free. If you like the show, you can show support by donating $1 to help with expenses. Just use the PayPal link on our website, YouTube channel, or Facebook page. Thanks.